lesson plan. See, last class we were not able to finish climatology. So today we will be wrapping up climatology. So only two more sections are remaining. Actually, technically three more. So lesson plan is this: three climatic regions: China, Laurentian, then finally polar climate. And as I told you, all these three things will make more sense when you're able to consolidate. So let me finish it off. And I was telling you, like, we'll be in a position to fix the climate chart in a particular continent, isn't it? So we'll try to fix it for two continents. I'll teach you for two. The other continents, I think you'll be in a position to do it on your own. Thing is, when you're able to do that, you'll be in a position to link both your physical geography and economic geography part. So it kind of wraps up several segments. And once we move to the next part, okay, so next section will be geomorphology. And in geomorphology, again, you will need at least 2 to 2.5 sessions for this. So today, I think two topics are possible. First is rocks, the basic types of rocks. We can definitely have an introduction, how you classify them, how you look into them. And second thing is, your interior of the earth. So whenever you start from the, earth perspective, okay, you try to break open. Okay, so we'll try to understand what is inside the egg, and then we'll come to the shell later. Is it okay? So let me start with China climate. Is it fine? So China climate. We are going to talk about the eastern margin climates, and as usual, which happens over every class, I misplaced my first slide. Wouldn't have time to flip over the messages also. Is it not? I'll do one thing. Let me take this off. I don't want this anymore. Really. Okay. Let the mistake be a mistake. Why try to correct it right now? Okay. As I told you. So China climate. China. So this is in your Gocheng Liang textbook. You will be looking at it as warm temperate eastern margin. So last session we ended with tropical marine climate. I believe so. Right. So right now we are here above India, China. Okay. So all the other sets are filled. 1, 4, 7, 8. So right now in the ninth climatic region. So let me start with the map section as usual. It is ready right there. Right, we got enough. Okay. See, there are no surprises in the starting position. So first is, as we get the name, China is considered as a proper representative of this climatic region. And please note, when we use the word China, we are not talking about all the parts of China. It is mostly to do with the southeastern section and possibly the eastern section of China. Okay, so maybe you can say, you can try to divide China into two parts, okay, and the southern section somewhere in the middle. And you also find some parts of Japan. Again, not all parts of Japan, but only parts of southern Japan, basically. So that is part of China climate. You move over to your America, then it becomes more and more stark. So this is the segment which you were familiar with, in map reading class, placing flowers over Florida, remember? So this is your Florida Peninsula. And if you look at the states which are actually involved right here, you'll find parts of your North Carolina, so your South Carolina, your Texas, So these are the states in the United States which kind of fall under this region, the southeastern part of United States of America. And moving south, okay, in the southern hemisphere, fine, this is a larger section of Argentina and Uruguay. Okay, not entire section again, a good section of Argentina, northern Argentina, and then Uruguay falls under this climate. And this again, as usual, every continent, every climatic region, if you would have observed, a small section of South Africa comes in, pitches in. Like on the western side, you would have seen Mediterranean, right? So here was Cape Town. So Cape Town was in the Mediterranean climate. This time you're on the eastern side. Okay, so this, you'll find cities like Natal and all that. And finally, a very small portion of Australia, as usual, and a very small pinch of New Zealand. I'd call it a pinch, very, very small section of the Northern Island. So Sydney falls under this climate. So that is what is called as China climate. Now, first thing is, there is one speciality of China climate. First, we'll start with the speciality. Okay. Usually, when you take a climatic region, there will be two variants. And if you remember steppe climate, we saw a variation for northern hemisphere and then one for southern hemisphere. But this climatic region has three variations. So if you get a statement, which of the climatic regions or this climatic region or this climatic type has three subclasses, this is China. So I'll start with that point. So this is the only climate, only climate type, only climatic region with three subtypes. Three subtypes. Okay. Ah, yes. Happy New Year. That's customary, right? I should say that. Fine. See whether I've completely lost faith in predictions and all that. Whether the new year will be happy or not, you'll only know on December 31st, 2021. As far as I know, 2020 did not go well. Yes, you can counter argue that I'm alive, of course, but still, New Year, happy or not, we'll see in December 31st, right? Now, starting from, if you want to really understand subtype, first we need to start from type, is it not? So what exactly is this China climate? Like, how do you define China? Then we'll understand variations. See, if you think about it, it's pretty easy to understand. If you know the basic differences of low pressure and high pressure, then they are formed over land. Is it okay? Let me show the climograph first. I'll show you the climograph, then I'll explain. So this is it. This is the basic type. And now you know to read it better, right? So this is your rainfall and this is your temperature. And if you look at your temperature variation, yes, summer and winter is properly differentiated because you're quite away. And if you look at the rainfall pattern, rainfall is present throughout the year. Now that is something. Usually you don't get that, right? So how does China get rainfall throughout the year? That is what we're going to understand. So let me start by explaining the summer peak in rainfall. Okay, that is simple. If you can understand the summer peak in rainfall, then the winter rainfall is guesswork. We'll see that. Okay. Let me start with this. So first, let's understand China type, the basic type. Okay, Korean Peninsula, Indochina. See, it's pretty simple. During my summer season, you know that based on the property of differential heating of land and water, the land masses will get much, much warmer. So surface temperature influences air temperature. This entire section will be in a low pressure conditions. Okay. You come to your northern Pacific Ocean, fine, off the coast of China and Korea and Japan, water will take a longer time to get heated. So you get a high pressure condition. Now wind blows from high pressure to low pressure, right? So you can clearly see this is technically a system where you have onshore winds. Wind is moving from sea to land, there will be good rainfall. That is why in China climate, you get a peak rainfall during summer season. Meaning makes sense. So pretty simple. So summer, okay, due to differential heating, onshore winds are established. Onshore winds are established, leading to summer rainfall peak. Very simple. Summer rainfall peak. Full stop. Okay, twist is there in winter. That is slightly tricky. We'll see how. Yes, happy surviving bad previous year. That is better. Very good. Okay. Now moving further. See, during winter season, you will find that there is a problem. Now, what problem are we trying to understand? Let me write winter. And if you've been following the class, you would clearly know. Winter season, the pressure systems usually get reversed. So land will become cooler faster. So you get a high pressure here. And then your water bodies will be in low pressure. Your sea surface temperature is quite warm. So naturally, wind gets to blow from high pressure to low pressure. Like this is normal. Now, point to be understood is this wind is an offshore wind. So if you're going to get an offshore wind, you should not be experiencing rainfall. You clearly know. But if you look at the climograph from the previous diagram, you would clearly know that I showed you that China climate experiences rainfall throughout the year. So how do you explain this contradiction? What phenomenon actually contributes to rainfall in China, even though wind system is predominantly offshore? The answer lies in something which you already know. Okay, like it's there in your mind, but maybe you may not be in a position to pick it up immediately. The answer is simple. Tropical cyclones. That's all. Okay. So The tropical cyclonic systems, as you all know, is more prominent during winter season because that is when the sea surface temperatures are quite warmer and they provide rainfall to China. Okay, so tropical cyclones predominant in winter, as sea surface temperature is warmer, SST. SST means the sea surface temperature. Is it clear? SST is warmer. Now, if you look at your climograph, you'll understand the basic difference. Like this is what is there. I'll draw it right here. So summer season, right? So summer season, there is a proper peak in rainfall. When you go to your winter season, yes, we do have rainfall, but cyclonic rainfall is much less when compared to the rainfall which you get from more of these wind systems, because wind systems are consistent and they provide rainfall for quite some time. But still, if someone asks you which defines a proper China climate, it is rainfall throughout the year, and this rainfall is characterized to an extent by reversal of wind systems. You can clearly see that between my summer and winter there is a good reversal, and this is not a monsoon. Like they call it a pseudo monsoon climate. Okay, if you want to establish something as a monsoon climate, you need to satisfy at least 2 to 3 basic criteria. Okay, not just reversal of winds. This is more of a pseudo monsoon climate. So your summer rainfall is contributed by wind system, winter rainfall by cyclonic systems. If you get these combinations, you can call the climate as a China climate. I think the basic idea is firmly established, right? So use the word finished if you're ready. We will look at subtypes. So what modifications are possible? This is a basic idea. So think about this. China experiences really good rainfall. Okay, see, India and China, geographic problem is there. Okay, like China experiences rainfall. That is at least a part of China experiences very good rainfall. We will see how it, kind of disturbs China's economic development also, like when we move to economic development. So second type is called as Gulf type. Let me write Gulf type here. Number 2, Gulf type. Now, usually when you use the word Gulf, especially in Kerala, it means the Persian Gulf. But we are not talking about Persian Gulf right here. We are talking about the Gulf of Mexico. Okay. So the first variation, so this is subtype, this is type 1, which we just saw right now. The second variation is right here in United States of America. That's the variation. So let me show the climograph. Number 2. So Gulf means Gulf of Mexico, not Persian Gulf. Right. So this is it. Okay. So again, do we have rainfall throughout the year? The answer is yes, of course. You can clearly see that. But point is, we don't have a peak in rainfall. Okay, you don't have a proper peak like China and then more dispersal of wind system. That's not more dispersal of rainfall. That's not how it is. You can clearly see that you have two consistent peaks. Okay, and you clearly cannot call it as peaks also. Like more or less, they have good evenly distributed rainfall. So what leads to this variation? Well, the answer lies in the shape of the continent, which is quite, which when you look at it, doesn't seem very prominent. But if you try to draw both your North America and your Eurasia together, you will find that there is some difference between Eurasia and North America. And that is what we will do and understand why there is no peak, no significant peak. You have two peaks, there are slight differences. So why are these variations happening? Why two? Why not a single one? You'll understand now. See? Let me draw them side by side. So this is, Malay Peninsula, Indochina, and Korea and Japan. So this is my China climate. Okay. This is my Asia. And this is my North America Gulf type. Okay. See, the answer lies in the latitudinal extent. Now, technically speaking, how wide the continent is. You might be like, what difference does it make? See, it's about how close can you or how intense can you develop a low pressure. Picture this. Summer season, this entire area is land. Is it not? So when you have an extensive land area, and if you're going to develop heating 90 to 120 days, and you develop a low pressure system, the low pressure system would be effective and it will be very large, right? Look at the size of North America and you compare it with the extent of Asia. North America is kind of tapering, it is broad, but it is broad only on the top. As the continent becomes, more and more moves towards the equator, the shape of the continent becomes narrower. So yes, during summer, will I develop a low pressure system? Yes, but the low pressure system is not very extensive as in the case of Asia. Is it clear? Why? Because North America is a narrow continent compared to the size of Eurasia. Meaning makes sense. So let me write that here. Gulf type. Even though summer heating develops a low pressure, it is not intense as developed over Asia. So this is pretty easy to understand. Larger land area, more intense. You make it more broader versus narrower. It cannot be intense. But how does this explain the absence of peak in rainfall? Very simple. So if you say that my pressure system is very, very intense, you say that the low pressure is very intense, then my wind system will be very consistent. Consistently, the winds which move from the sea will move over larger area, and the velocity of the winds will be very, very powerful. So you will definitely note a consistent peak in rainfall, because it's the low pressure after all which invites the winds in from the sea. Okay, if you're going to have very good low pressure, the wind system will be very stronger, leading to good onshore wind rainfall. Very, very good. Now, opposite case, if you take this case, for example, now when you say that, see, I am developing a low pressure, but the low pressure is not as high as it used to be, you will get rainfall. Yes, no doubt at all. But the rainfall is not going to be extremely high as it used to be. You will not distinguish between the summer and winter rainfall. Meaning makes sense. So that is the reason why your low pressure, like winds will be there, but winds will not be as strong as you see with reference to your China. That is the reason. Now let's go to the second part. Second part is this. This case is fine. Now, what about your winter rainfall? Like, how can you expect that during your late months of October, late months of November, you get very, very good rainfall? Well, the point is this. You take your Gulf of Mexico, the hurricanes are much more intense because of the presence of a warm ocean current. So this ocean current makes sure that the surface temperatures are quite high, contributing to rainfall. Now let me make this simple. So far, we haven't seen what are ocean currents, right? So if you do not know what are ocean currents, there might be slight problem in understanding. Let me put it this way. See, just try to visualize ocean currents right now, which we will discuss later, of course, as warm surface waters. Okay, warm surface waters which are moving like rivers on land. So similar to that, you have rivers in the ocean, very, very warm. So these ocean current, there is an ocean current which is present right here, right there. Okay. So this ocean current, which is called as Gulf Stream, plays an important role in providing very good moisture and precipitation in this region. So if you look at your hurricane intensity or tropical cyclone intensity, you compare it with what is happening in China and you compare it with the United States, this is much more prominent because there is consistency in surface temperature. Is it okay? Don't worry, like this point, we will come back again when we learn ocean currents. Okay, it might seem premature, but still I have to give it to you. Is it clear? So let me write that. So you take winter rainfall, the hurricane intensity is much higher, because of Gulf Stream. The discussion will make more sense when ocean currents are done, but still, just understand warm ocean current. The surface water is warm, you will get warm sea surface temperature. That's the way it goes. In Gulf type Chinese climate, slope of pressure gradient is lower than Asia. Right? Yes, Nilarjyoti, you're right. Correct. Good. The pressure gradient, the intensity is less. Good. Okay. So use the word finished if you're ready. So Florida, very, very, more prominently attacked by your cyclonic systems. Is it clear? Thank you. Now moving on. Why exactly do we have a third type? Well, third type, the answer lies in steppe climate actually. It's not right here. Okay, it's there in steppe climate, and let me show you the climograph, you will understand. See right now. You see that? Do we have rainfall? Yes. Do we have rainfall throughout the year? Yes. But there is no concept of peak at all. Simply flat curve. This is natal type. Now, what is or who are the representatives of natal type? If you ask me, well, we are talking about these places. All the regions in the southern hemisphere, Argentina, Uruguay, South Africa, and Sydney. Okay, these form the third type. Okay, like this is a common type which is present in the southern hemisphere. Now, why exactly? Let me write the statement. Let's see whether you can get the idea, because this has been taught in the previous session. Let me write it for you. Hold on. Number 3 is natal type. See, natal, I think you know where it is. A great man lived here. Mohandas Karamchand Gandhi, right? So he started Natal Indian Congress. So it is in northeastern part of South Africa. And he served, he spearheaded the Satyagraha movement, back here, where he had his own paper, I think New India, I think the journal or the newspaper, I'm not able to recollect the name of the newspaper. So he was here. So Natal is in South Africa, very important place for Gandhi's, let's just say evolution as an important leader. So natal type, okay. The subtype in the southern hemisphere, has even distribution of rainfall, and no prominent wind reversals. As seen in the northern hemisphere, because, very simple answer, you know this from STEPI climate. That's why I'm not really explaining it in detail, because of moderating influence of the sea. That's it. Influence of the sea. Okay, within bracket you write peninsular shape of the continents. Peninsular shape of continents. Full stop. Let me explain with the map section, no worries. Hope you're ready. I'll read it again, then I'll flip over. The subtype in the southern hemisphere has even distribution of rainfall and no prominent wind reversal as seen in the northern hemisphere because of moderating influence of the sea, which is technically brought over with peninsular shape of the continents, right? So let me go to the diagram again, the map section. So you take these regions, for example, right? See, when your continent takes this type of structure, okay, so you will have land here, right? So it's already a peninsula, which means you're opening your land to more and more moderation. There is water, there is water, there is water. So the influence of water becomes more and more prominent. So between my summer and winter season, you will not develop very strong pressure differences between land and water, even if it is available. You take here, same problem. Yes, there is land, but still, the continent is becoming more and more tapered, peninsula. So water again, like water will make sure that your land doesn't develop very, very intense low pressure. There is always some sort of circulation or some sort of moderation. That presence is there. Because of this, you will not have all the winds moving in one season and all the winds reversing in one season. That's not possible at all. Really makes sense. So that's the reason it's a very flat climatic region found throughout southern hemisphere. You take Australia, you'll find it's even more ridiculous. Okay, this very small region. Very, very small region. Okay, just the area. And this is peninsular, this one. So that's not a prominent color. We use red. Again, so you have land, water, water. So again, the influence is there. Got the idea? So this section of Australia, we're talking about this narrow section, eastern side. Meaning makes sense. So now we'll understand a unique type of natural vegetation. Like in China climate, we have something which is slightly different from the usual climatic regions. Usually, When we talk about the natural vegetation of a climate, we will restrict ourselves to temperature and precipitation. This time we need to compare China with two other climates. We'll see how it goes. Natural vegetation, and it's an account of location. Slightly different. See this right now. See, it works like this. China. South of China, we have tropical monsoon or tropical marine. This you know. North of this, we'll see Laurentian. See, China somewhere in the middle. Okay. Now, what is the situation here is, if you look at Chinese type, there will be certain parts of your monsoon forest. Okay, so they will slowly start invading into Chinese climate. See, when it comes to climate, there is no abrupt end except for mountains, I've told you. So some types of your monsoon species will try to move over to China. You take a Laurentian climate, it does not exactly start at the boundary. So some species of the next climate, which you will see right now, Laurentian species, the temperate forest, will also be present in China climate. Now, at the same time, China itself will have its own original species. You get the idea. So when you move across your eastern coast, and if you're stranded in China climate, you will find that here you get some sort of a mixed forest, okay, mixed temperate forest. Again, please note, we are not talking about very high biodiversity. Thing is, you cannot define that you take China climate, this is the only type of forest type available. You take biodiversity is maximum in the equatorial region. Tropical rainforest, tropical evergreen forest, no doubt at all. But here, you will find types of forest areas. You will find a China type of forest. You'll find forest types of monsoon. You will find forest type of Laurentian. Okay, that's why we call this region as mixed forest. Is it clear? So let me write that here. So it's kind of unique. You might ask me, well, this is the case. Why doesn't it happen here? Because after all, Mediterranean should be having that type of mixed forest. I'll tell you the reason why. Desert, what type of forest will be there? You tell me. Desert is completely barren. So here you cannot have that level of biodiversity. You take here, of course, you can argue like we have thorn forest, but thorn forest is technically not a forest. Cactus will be here and there. Desert will be here and there. That's all. This is a forest area. Monsoon, you get deciduous forest, several types will be here. That is why in Mediterranean, you don't get that merged. And already Mediterranean, there is a problem. Dry summer. You take monsoon, high rainfall. China, high rainfall. Laurentian, we will see again. Again, rainfall will be high. So all these three regions, very good amount of rainfall. You take western side, one person is having dry summer, one person no rainfall at all. That is why you don't get it on the western side. But eastern side in China, there is some speciality. I think you're able to link with these two regions. Okay, so let me put it this way. So in China type, in China, there is mixed forest, as it is the transition zone, as it is the transition zone between the marine, the tropical marine or monsoon forests in the south, monsoon forests in the south, and the temperate forests of the north. Laurentian temperate forests of the north. Of the north. So you get mixed forests. That is a natural vegetation. Mixture. And just like Amitabh Bachchan says. So in China, there is mixed forest, as it is a transition zone between tropical marine or monsoon forest in the south and the Laurentian temperate forest of the north. Now we'll try to understand economic development, and it is slightly different between Asia and North America. You clearly know. Some link with world history also, you'll get the idea. So shall I move on? Just let me know if you've taken this down. See, in case anyone asks you why it is not possible in the western side also, you should be in a position to explain. Desert, like pretty much absence of forest area. Mediterranean, already species is sclerophyll, dry summer. So that also you should understand. Why it's on the eastern side, why not in the west? So first, as usual, we'll understand what is given in your textbook, and then we will try to extrapolate how things has changed in the contemporary times. First of all, these regions of the world are known for intensive agriculture. The reason being there is rainfall throughout the year. And if you can have good temperature, look at the latitude here. For example, you're slightly away from tropical region. We'll take this. So this is my Tropic of Cancer. And you know about Miami. Miami is one of the sunniest places. You know, you take most of the films right here. And you have Texas and you have the states of North Carolina, South Carolina. So it's quite sunny. So we are right now at 32 degrees, 35 degrees. Okay. You take China. China, I don't think I should explain. You have just north of Vietnam. So the temperature is very, very good. You're talking about a very a thick jungle. So here also, good temperature, good rainfall. So naturally, if there is good temperature, if there is good rainfall, your first option will be to go for agriculture. And that is what they did. Fine. So what type of agriculture? That is something you need to understand. Here, unlike your steppe climates, you're not talking about extensive wheat cultivation. They didn't do it. They went for something much more vigorous. As rainfall is present throughout the year, rainfall is there throughout the year. At the same time, temperature is good, okay, high temperature. Of course, there is a winter, okay, but you get very good temperatures. They went for intensive agriculture. Intensive agriculture. Okay, you take China, it was mostly food crops, especially rice we are talking about. That's a staple food. You take United States of America, it is mostly cash crops. Cash crops. You're talking about tobacco, sugarcane. Right. Now, some of, like, you will be familiar, but still, let me explain in case you're not familiar with. Like, what do you mean by extensive versus intensive? Like, what exactly does it mean? See, extensive is a type of agriculture where you're talking about scale. That's all. Extensive is about scale. How large an area can be cultivated. This is something which you saw in steppe climate. You know, wheat farms extending for 350 acres, 400 acres, 500 acres. That is extensive. Intensive is something which we practice in India also. When it comes to intensive agriculture, we are talking about productivity, efficiency. See, if I have only few acres of land available, okay, how efficient can I cultivate to get the maximum output? We are talking about, X amount of tons or X amount of crops produced per hectare, per acre. So you want to improve that per, something like we have the government policy, per drop, more crop, something like that. You want to really make it much more productive. That is intensive. Now, if you take China, there is a historical reason like why it is only domination of rice. That is a staple food. So there is more domination of food crops. And there is a historical reason why cash crops are dominant in the United States. Because that is why they went there. Okay, this has been something which is practiced for more than 300 or 350 years. Right since the arrival of the Europeans, they wanted to make sure that they cultivate tobacco and sugarcane only for selling in the European market. There is no other reason. So even after the formation of the United States, even after your civil war, this prominently continued. Is it clear? And let me tell you the today's scenario. Today's scenario, what is existing, how things has changed. See, first let's talk about USA, because things has not really changed too much. Okay, because the book was written in 1970s and till today, of course, there is some sort of change in demography. But if you look at the plantations do continue to exist. Why? United States of America likes to smoke. They smoke too much. So tobacco plantations continues to exist because at the end of the day, you need to feed local demand. Okay, and the consumers of tobacco has only increased. Even though people say that smoking causes cancer, no one is going to stop because people get addicted. Okay, it's very difficult to come out of addiction. So tobacco plantations exist. Sugarcane plantations also exist. Now, some change which you need to understand in terms of USA's agricultural pattern, how things change. We'll just end with that. Then we go to Asia. This is very narrow. I'd rather draw this Florida Peninsula alone. Okay. The thing is, in this section of southeastern portion of America, you will get tobacco and sugarcane cultivation. You move to the central region of USA, here there will be domination of wheat. Okay, extending as far as Canada. Now, in between them, there will be corn. Corn always gets more of stepmotherly treatment. Okay, because tobacco is important for the climatic region, high temperature. So this is more of a tropical crop. Wheat is something important as a temperate crop. So both these crops, provide you with more value. Your economic value is more because human beings consume. You take corn on the other hand, corn is something which is fed to, cows. It's fed to pigs. So that is the reason this really does not have that importance. So it's kind of in the middle. So it's peripheral to temperate, peripheral to tropical also. So if you're going to travel along a national highway from the coastal area of the United States and you travel in between, this is how your fields are going to change from sugarcane, tobacco to corn to wheat. Is it clear? Now, some information on demographics of North America too. If you've done this, some history, okay. So that you'll be in a position to link. Like in case you get any relation with current affairs, I just want to add this point. See, if you look at USA was split into southern colonies and northern colonies during the Civil War, primarily because on the question of slavery. We've seen this in map reading. But we really didn't understand the climatic reasons, isn't it? So you take the southern section is more closer to tropical region. This is where most of your plantations were present, right here. Plantations. Okay. That is the reason the southern states in the 1860s were really not ready to, abolish slavery. Because if you're going to abolish slavery, at the end of the day, it will be the southern states who stand to lose because they will need workers to work in plantations. You take the northern states, for example, northern states are temperate. Okay, like you want an example, think about New York, Chicago. Like New York and Chicago, you might have seen in films where the entire streets are filled with snowfall. You take Miami is very sunny, is it not? You have the beach and all that. So this is temperate. So your northern states did not need slavery. There is no necessity of slaves because they were not operating based on plantations. Your northern part was always industrial. You had fishing. Okay, you had other markets, techniques which were related to manufacturing. Your Chicago, Detroit, all of them will form in the temperate region. So this was more of the manufacturing portion of the United States, and this is the agricultural portion of the United States. And only based on this, your northern states and southern states were divided based on Civil War. So technically, geography played a role in determining the division between the United States. Even today, it is true to an extent. Second point about demographics. See, even today, if you look at African American population distribution in United States, it'll mostly be concentrated in the South because this is where they were initially settled. Fine. So even if there was migration, it was not very extensive. Still a good portion is right here. Is it okay? So those two are peripheral points, even though not strictly geography. Now let's talk about China. Okay. What has happened? See, China exploited this portion really well. Okay, like this is where today, if you take, apart from your agricultural land, which of course has shifted north, you have a good portion of special economic zones and industrialization coming in. That's a very, very big change in China. So let me add that. So in China, it's more stark. What's happened in China is much higher than what happened in the last few decades. Apart from intensive agriculture, there was development of SEZs. See, all your major towns, your Hong Kong, okay, Guangzhou, okay, Fuzhou, Macau, and all of them are located here, which you would have seen in map reading. Is it clear? So that's why the urban population is very, very high in southeastern part of China. So those are different changes which has happened. So if they ask about this region, apart from your agricultural part, you can also say this has become more industrial. In an example, you can quote Hong Kong and Guangzhou. Basically, Guangzhou is Canton. It used to be called as Canton. So that ends the discussion on your China climate. Okay, so I believe you've taken down. Next is your Laurentian. Okay, Laurentian, we'll be in a position to compare the North American section and Asian section again, but it won't be as elaborate as we see right here, because one point I'll need to reserve for your ocean currents. Is it fine? So let me give the basic idea of Laurentian right now. Laurentian climate, number 10. Laurentian climate. Right there. So you're moving further north. Okay, further. So this will just be a contradiction. We were discussing about southern USA and southern China, isn't it? So if you look at the map, you'll get it. It's about the northern part of United States and northern part of China. First point you need to understand, there is no climate in the southern hemisphere. Laurentian doesn't exist. We saw one more climate in the northern hemisphere similar to that. It was Siberian climate. Why? Because land is absent. Since land is absent, the climate is not present in the southern hemisphere. Point 2. So you have variations here also. So subclass variations between two places. One is, as I zoom in, so you can clearly see northern part of China. Like this is where you find your Shandong Peninsula and your Beijing. Fine. Your Korea, North and South Korea, and a larger section of Japan. Okay, Japan experiencing snowfall, Kill Bill fight scenes and all that. So it's actually shot here. You cannot shoot those sequences in the southern portion of Japan. Okay, all your autumn blossoms, right? Let's come back to North America. So in North America, this is the region where you had your TUMC. You remember TUMC, Toronto, Ottawa, Montreal, Quebec, your Labrador, Newfoundland, and all that. So those regions, okay, are actually here. You're talking about New York, Philadelphia, Boston. Is it clear? So those regions. Now let me open the climograph, okay, so that you get the variations right here. The climograph is there. First, we'll start from Asia. Very simple. Summer, there is rainfall. Winter, there is no rainfall. Okay, winter season, there is pretty much nil. We need to understand why. And after this, I'm going to ask you a question after explaining. See? Both of them are completely different. So you take your Asia. I'll draw the same diagram. Asian type. Same thing. China, Korea, Japan. Okay. This is the region. Summer season. I'll try to use a different color, possibly green. Land, surface temperature influences air temperature, land becomes warmer. Water will be colder, surface temperature influences air temperature, air becomes colder, air begins to settle down. Wind blows from high pressure to low pressure. Same story I taught you in China climate also, which means during summer season, there is peak rainfall. Okay, now winter season, reverse will happen. Land will be at a high pressure. Water will be at a low pressure. Wind blows from high pressure to low pressure. Okay, high pressure to low pressure, absence of rainfall. There is absolutely no rainfall or very, very nil rainfall. I have a question. We saw the same reason for China climate also. But in China climate, I did tell you, you received rainfall in cyclonic systems. There was rainfall due to cyclonic systems. Why are they absent here? Give me an answer. Like I drew the same diagram for that also. Like why is it absent? Like why did we have it in China but why not here? Simple answer only. Don't think too much. If you think too much, you'll make mistake. Simplest answer which comes to your mind. I've got 10 answers. I don't want to read. I will feel bad. Appa, one person had 15 answers had crossed. People, it is temperate zone. Tropical region, only sea surface temperature will be warmer during winter. That is where you get tropical cyclone. Look at the map right here. That should be the simplest answer. Again, Tropic of Cancer is actually here. Here you will get cyclone. Okay, cyclone, typhoons will come and attack this region. You take this region, okay, here there is no concept of tropical cyclones moving as far as 45 degree, 50 degree. Here you will get cyclones, but what type of cyclones? You will get temperate cyclones. Here. Okay. If temperate cyclones are present, you clearly know the idea. Temperate cyclones can form over land. At the same time, they can form over water. Moreover, they are driven by westerlies. Their rainfall pattern will be totally different. It's not necessarily the cyclones will be pushed towards this region. They can form anywhere. They can provide rainfall even here. They can provide rainfall here. It doesn't really matter. Temperate cyclones are more widespread because after all, it's a result of frontogenesis. Meaning makes sense. You have this variation because this is in the temperate zone. You just write the statement, it will be enough. It is in temperate zone. That is why you don't get cyclones here. I mean, you don't get hurricanes here. So you will get temperate cyclones, but temperate cyclones are more widely distributed. More widely distributed. They can happen anywhere. So there is no restriction that they should give rainfall to northern China. Widely distributed. As simple as that. Now we'll read the answer what you sent. Not peninsular shape. Japan exists in middle. Surface temperature not that high, question mark. Gobi Desert. Landlocked in northern. What people? Why giving so many answers? Simple answer is enough, no. One person, no, not possible, mixed climate. Interview, they should ask you this. Then they will answer. சும்மா அடிச்சு விடுறது. In Tamil they will say, போடு சும்மா போடு, சொல்லு சும்மா சொல்லி பாரு. There is a character called Sunapana. Non-Tamil speakers, you should know about Vadivel. Vadivel is a very big legend comedian, okay, and he played a character called Sunapana. And Sunapana is kind of a person who tries to manage everything. Whatever happens, he'll give some answer. Okay, that will work in real life, but in exam it doesn't. So I think you got the idea. I'll repeat again. This Laurentian climate is in temperate region. Temperate region, you will get rainfall because of cyclones only through frontogenesis. Frontogenesis is more widely distributed. Since it is widely distributed, it is not necessary. It should definitely rain here or here. Okay, it's not necessary that it should be present only on the eastern side. It can be present on the western side. It can be present on the center also. So more widely spacing. That is why the climograph does not say winter rainfall should definitely happen. Not necessarily. Okay. Now we'll have a problem if you look at that climate. Idu okay. Okay, you take North America, I'll show you the climograph. Problem. How do you explain rainfall throughout the year? You give me answer. How do you explain this? No Sunapana answer. No Sunapana answer, no. See, thing is, I will never ask you a question without giving you inputs. Think about North America, the location will get the answer. Few more seconds, then I'll give the answer myself. Nothing is coming. I'll say. You will say something, then I will feel bad. Why? People, the answer lies in North America because you're missing something very fundamental in North America. It's very special. That kind of defines North American climate, especially for this region. Superman helps everyone. I think you remember. Lake Superior, Lake Michigan, Lake Huron, Lake Erie, Lake Ontario. The 5 Great Lakes of North America play an important role in modifying the climate. Is it clear? So this is what is considered as a Laurentian climate, right? Like this region. Okay. So now you have 5 large water bodies. These water bodies were not present in China. Now, because of these water bodies, what is the advantage? Okay, let me explain both summer season and winter season. This is my all these 5 fingers. Is it clear? See, so let me write it there and come back to this location again. I will need the map, but still, I'll write the description. So North America variation. While in Asia, there is concentration of rainfall, only for few months. In the Americas, North America, even distribution is brought about by the Great Lakes. And the Gulf Stream. No problem, you can reserve the Gulf Stream. Great Lakes itself will be sufficient for you to understand how these 5 fingers, usually when I mention 5 fingers, people automatically think about Pangong Tso Lake because that was frequently in news, but yes, these are 5 Great Lakes, so it is applicable here too. While in Asia, there is concentration of rainfall only for a few months of the year. In the North American continent, even distribution is brought about by the Great Lakes and the Gulf Stream. Gulf Stream will reserve, no problem. So what does Great Lake do? Well, Great Lake helps in moderation again, because you're talking about 5 large-scale freshwater bodies which has the potential to moderate the climate. So during your summer season, okay, compared to your Asian continent, you will not be in a position to develop very, very high temperatures and a uniform low pressure because lakes meddle with the pressure system. So let me put it this way. So during summer, the lakes bring about moderation because land water, so your temperature is not going to peak. Bring about moderation, thus preventing peak rainfall. You're not going to get very, very high rainfall. Now, winter season, you get a beauty right here. Okay, winter season. The westerlies carry moisture to the eastern coast. Now, if you look at the diagram, you'll get the idea. First, copy the statement. Okay. We'll see how. Yeah, Gulf Stream is correct. Gulf Stream is an acceptable answer, but to appreciate Gulf Stream, it's better we stay for ocean current. Gulf Stream is very, very good. That's a good answer. So let me show you the diagram right now. I'll read it again. During summer, the lakes bring about moderation. During winter, westerlies play an important role in transferring moisture. Look at the diagram right now. This is my physical map. So this is my westerlies. And look at the location of Great Lakes. Like these are my lake region, right? Okay, and this is my coastal area. Now you tell me, as the wind systems move from water body to land area, it's very natural. They will collect moisture from these lakes and then pour over to this region. So winter rainfall is actually facilitated by the presence of these water bodies. This is one reason. We also have a reason by air masses, but maybe we'll take it up later. It requires more relationship with formation of air masses and all that. If you get the basic idea, it will be enough. Okay, so westerlies. So you can just take this rough diagram. Westerlies, Great Lakes are there. So you just transfer moisture from Great Lakes and then push it towards this region. Is it clear? So they facilitate the precipitation in winter season. Okay. Rocky Mountain present on the eastern side. So how is it possible? See, Rocky Mountain, let it be present, no issues at all. You're talking about a permanent wind system. You're not talking about local winds. Fine. Let it rise up the Rocky Mountain. Let it become adiabatically compressed. Again, westerlies will move in this direction only, no? Okay, doesn't mean that you'll be in a position to block out the entire system. Wherever your pressure belt is present, from here, westerlies will be blowing. Is it clear? So they just move from here to here, they collect moisture, then pour it in. That's all. Okay, we're not talking about an isolated wind. We're talking about a belt of wind system. The entire belt is dominated by westerlies. Meaning makes sense. Just write this down. Like westerlies, then you have your Great Lakes, then you have the Laurentian climate areas. If you got this order right, then you'll understand. As simple as that. Okay. So now shall we go to economic development? Just let me know if you're finished. So Rocky Mountain can only block local winds. You cannot push, permanent wind system, which is of macro scale. That's not possible. Yes, multiple responses. So now let's go to economic development. Again, one statement you'll have to take for granted right now. Like I will go to natural vegetation and economic development, but one statement I will keep it as reserve. It can be explained well only during your oceanography class because it requires input from oceans. That is why. So first, let me finish natural vegetation. Natural vegetation. See, here you have two types. Two types meaning British, Siberian, Laurentian. British climate, deciduous forest. Siberian climate, coniferous. Coniferous, right? Right there. See, the coniferous forest from the taiga region begins to invade into Laurentian. So some part of Laurentian climate will have the influence of Siberian forest area. So this will try to invade. So one section will become automatically coniferous. So this is my continental section, more continentality, more continental. Continental, now I am reminded of food only. Hope you are not. If I'm reminded of food, it means hungry. You come to the eastern side, it's more coastal. Since it's more coastal, you will naturally know that there is help from the sea, which prevents you from severity of weather conditions. So similar to deciduous forest, here also you get deciduous forest. So in Laurentian climate, you got two types. Coastal areas, domination of deciduous. From deciduous, you move interior. Automatically, it becomes coniferous. Continental region, coniferous. Coastal regions, deciduous. That is with Laurentian. Right. Let me write the economic development here. See, the most important economic activity which defines this region is fishing. It's only because of fishing that a good amount of industrialization is brought up, but that explanation will require the help of ocean currents. So right now, write this statement and keep. I will explain later. Just remind me when I deal with oceans. That's all I want. Fishing is the most dominant industry because off the coast of this climate, warm and cold ocean currents meet. Ocean currents meet. Now, I'd like to just relate a point which you might have learned in map reading. If you remember, when we spoke about shipping industry, we would have seen that Korea is a major player and Japan is a major player. Why exactly? Because traditionally they've been important fishing nations, so it's very natural for them to get involved in manufacturing of ships, manufacturing of boats. So the manufacturing industry is closely related to your primary sector here. You want to fish, then naturally there is more requirement of boats and ships. So that technology got passed on for several years and they still continue, even if they learned the different techniques during industrial revolution. So that's some point which is relating to fishing. Fine. Number two, you do have lumbering here also. Since there is a section of coniferous forest, you also have industries related to lumbering, just like your Siberian climate, because the section has coniferous forest. Okay. Right. So now to the last climate. Okay, polar. Believe you're done. Last one. After that, I will give you consolidation, and after consolidation, I think we'll go for the break. Polar climate will take only 3 minutes. I'm not going to spend more time on that. Polar. Let's go to the map section. So we'll just look more about the geographical part, because climatic section I really do not have explanation to do. See, you're talking about regions which are technically present in the Arctic Circle. That's all. You're talking about the northernmost section of Russia, the northernmost section. Like all those, parts of Finland, like this is one region maybe you should know, that this is northern Finland, and some part of Russia will be here. Here's where you have Murmansk port. I believe you remember in map reading, I told you, Murmansk port, 10 months it remains ice-free. It's right there. Okay. When I say map reading, people begin to smile. I don't know why. I did teach you. I did. I absolutely did. Moving towards this region. Okay. I moved towards North America. Okay. So this is where you had these places, Baffin Island, Greenland, Queen Elizabeth Islands, larger section of Alaska. Okay. All of these we saw. Great Bear, Great Slave. Remember those lake regions? Hudson Bay, larger section comes under this polar climate. Okay. All those regions we saw in map again. Fine. I'm just going to contrast with the equatorial climate, because climograph, nothing is there. If you want to show me climograph, I will show. Look at the x-axis. Zeros here. I think you can understand. It makes sense. Rainfall is practically nil. Even if precipitation is there, it will be in the form of snow. There is no concept of rain at all. Compare with equatorial, we'll get the idea. Temperature is high. Rainfall is extremely high. Biodiversity is very, very high. Inge, temperature is extremely low. Rainfall is extremely low. Biodiversity is extremely low. Natural vegetation, okay. You do not have large trees and nothing. You only have primitive organisms. Natural vegetation. You have mosses and lichens or lichens, however you want to pronounce. I do not know whether environment class has started, but sir would definitely talk about the species. So this is a symbiotic association. Symbiosis. Biosis between two plants, two organisms, algae and fungi. Okay. So fungi is an organism which is saprophytic in nutrition, but still fungi can produce or they can really give you very good roots to hold on, root system for properly holding on to an area. You take algae, algae does not have very well developed root system, but algae is very good in photosynthesis, food. So these two organisms together can survive in these conditions. See, even for them, even for these primitive organisms, survival is very difficult. That is why they join together. Okay. And they survive. Right. Now to talk about economic development. See, in this region, what do they traditionally do? See, this is where you have tribes, and you would have definitely known about Eskimos living in igloos. It's a fascination, isn't it, when you were children? So it's technically about people trying to live a nomadic lifestyle, because most of the time you have very difficult access to resources. Even if you take your Arctic waters, during summer it might melt, but during winter it is completely frozen. Now, point to be noted, apart from climate change, apart from the threat of anthropogenic emissions, you need to understand that this region is closely watched by different parts of the world. Why exactly it is? Well, because it has resources. So this is for the future, not today, but today and tomorrow. The Arctic region, that is your polar climate, is very rich in resources. So how rich, you ask me? I'm talking about all the elements in the periodic table. all elements in the periodic table. Okay, it might seem to be an overstatement. No, I'm not joking. Okay, because it was never touched ever. It is pristine, it is pure. If due to glacial melting, large amount of area is going to get exposed, one of the countries which will be extremely happy will be Russia, because Russia does get a large amount of land area where they can exploit large amount of resources. See, that is why if you think about one international organization linked with current affairs, Arctic Council. Okay, just tell me whether you can answer this question. I think IO would have started. Is India a member of Arctic Council? Is India a member of Arctic Council? No, good. Yes. There should not be any confusion. India is not a member of Arctic Circle. No, not a member. India is an observer. You know why? We can only be observers. You know why? Because, see, Arctic Council was formed in the year 1996. Look at the objective of the organization. The organization will say that we are actually forming this organization for protecting the environment, protecting the Arctic, protecting polar bears and all that. I'll tell you the actual reason. The organization only has 8 members. If you want to become a member of this organization, then your territory should be inside Arctic Circle. Inside Arctic Circle. Why this condition was put is, of the 8 members whose territory is inside the Arctic Circle, 2 countries are very bad. Idu onnu, idu innonu. USA and Russia played the cards really well. They did not want any other powerful countries to compete for resources in the Arctic region. That is why, like, if you want to exploit any resources in the Arctic, you need the permission of USA and Russia. Without it's not possible. So Russian side of resources, Russia is going to exploit. And the United States side, United States has Alaska. So the resources through Alaskan side, the Americans are going to exploit. Meaning makes sense. So that's why it's an important area where, not much resources has been explored, but it will be an important geopolitical game in the future. Is it okay? We too have Himalayan polar region. Why not a member? See, Himalaya is okay. Polar region, for polar region, they did not give Arctic Council. Your territory should be there in Arctic Circle. India is a tropical country. That's all. Why forest fires took place in Siberian forest region? See, first understand that forest fires is a very, very normal phenomenon. First thing is, forest fire is not something abnormal. Forest fires naturally happen. When tree density increases, if in certain areas, you get blocking highs. Blocking highs are nothing. Okay, you get a large area. Blocking high simply means a consistent high pressure system. And it's very natural. During winter season, okay, if you have a jet stream which is meandering, meanders like this, a jet stream which is meandering, the circulation is actually created, and properly this high pressure system settles over a large area, you will create adiabatic compression, and there are very good possibilities that you will create forest fires, which is normal. It's not something to be afraid of. Forest fires have become more dramatic in the last few years. That is why people are afraid. Fires are a normal phenomenon. They become disasters only because of human activities. So a consistent high pressure region can facilitate more heating, adiabatic compression, due to meandering of jet streams. This you already know. Is it clear? So one more question, I think, then I'll explain it. Then I'll give you a break. Just give me 5 more minutes for explaining this part. Okay. Majority months to have sub-zero temperatures, but it's mostly above zero. This is the problem. See, thing is, you didn't look at the graph carefully. See, please don't be fooled by this graph, because the question is this: 0 degree is there, which means it is not experiencing minus. Correct? This is 0 degree Fahrenheit. 32 degree Fahrenheit itself is 0 degree Celsius. You go to 0 degree Fahrenheit, you'll be in minus already. Is it clear? It's Fahrenheit, not Celsius. Got the idea? I think you would have got it. Okay, 32 degree Fahrenheit itself is 0 degree Celsius. So we're talking about F, Fahrenheit right here. Believe you got it? Hope so. Moving on. So now, how do you study climatology? Physical geography and human geography link. Some will ask me, what is this? On a side, I will write the actual climate also. Equatorial, desert, British, Mediterranean, savanna, steppe, Siberian, tropical marine, monsoon, China, Laurentian, polar. Astrology map of the world, I told, no, it will properly fix. See, there is no concept of equatorial climates when it comes to North America, because North America does not extend as far as equator. South America will be there. So that's why equatorial climate is not absent, is absent. Number one. Western side, equator is not there. Western side, desert climate. Why? Offshore trade wind. Trade winds are offshore. That's why you get desert right there. This region, US-Mexico border, you get deserts. Same trade winds I will draw here. See what happens. You get the idea. If on the western side, winds are going to be offshore and create deserts, on the eastern side, winds are going to be onshore throughout the year. Wind is going to move from sea to land, which means you'll get rainfall throughout the year. Now see what happens. There is a beauty here. Either tropical marine climate. Savanna climate won't be in North America. Why? Because land is not there. Entire land area available is a very, very small cone, a very, very narrow area. One side becomes deserts, the other side is actually under the influence of trade winds. That is why there is absence of savanna climate in North America. If North America is more wider, then central region will be there. There you will create savanna climate. Got the idea? Mala. Here. Trade winds are there. North of this you get British climate. British Columbia. Simple. In between my desert climate and British climate, you will find your Mediterranean climate. Mediterranean climate, both the wind systems will be there. Okay. So I have my westerlies, at the same time I have my trade winds also. This is California. So US-Mexico border, California, where I experience my Mediterranean climate. North of California is where you get Canada. So this is British Columbia. Got the idea? So deserts, British, Mediterranean. Savanna climate is not there, right? Mediterranean is done. Since savanna is not there, automatically the northern climate becomes steppe. This is the region where extensive wheat cultivation is done, and this is why your population of North America, that is central North America, including parts of USA and Canada, not much people live. So this is my steppe climate. That is your prairies. Very, very large area of extensive wheat cultivation. You move north of that, this is my US-Canada border where steppe ends. And north of this, you get your Siberian climate of coniferous forest. Conifers. This is where lumbering is a major economic activity. You take Canada. Canada's important industry. You've seen a Canada map. See, not map. Canada flag. One leaf will be there. Okay, that's technically a tree. It's your maple leaf. And this is that's your basic industry in Canada, lumbering industry. Meaning makes sense. You come towards your southeastern side. This is what we spend time today. This is your Florida, right? So this is where you get your tropical intense climate. So your China climate, subtype. Number 2. Florida, all the southern states where plantation agriculture is very, very high. So more agricultural. Your Laurentian side is more industrial. This is more industrial side. This is where you got your Laurentian. If you think carefully, this is where you find your Great Lakes. Presence of Great Lakes facilitated the development of industries because all the lakes were connected. So it's much easier for you to trade with the eastern side. So once you cross the Atlantic Ocean, you will find Britain. For the last 150 to 200 years, most of your industrial development was concentrated in this region. That's why the major states of USA will be present here. You come towards the southern side, more agricultural. Okay. Finally, polar climates, where population is very nil. So if you've done this, then any continent of the world, absolutely no problem. Okay. Same climate chart you can fix for anything. I thought I'll do for 2 continents, but I think one continent itself should give you the idea how exactly to use it. So this is how we learn. After finishing climatic regions, if you can draw the particular continent, okay, and you can relate with human geography, not with physical geography alone. It's much easier. Physical geography is fine. But human geography, why these areas are more developed, why population is less in certain sections, what could be the historical factors? You think all that, then your mains perspective will explode. You can interconnect a network so many points. Okay, so I believe this was helpful. You can do it for several other continents also. Fine. So take a break for 5 minutes. Mhm. So when we come back, we are entering the next chapter, geomorphology. 5 minutes. fix the map for other continents also for better understanding. How can we make climate chart for Africa? Done. We will do. See, I'll do it at the last maybe. Okay, like we'll do it, no problem. I'll do it for South America. Africa is slightly tricky. Africa is very easy actually. I'll tell you what to do for Africa. South America, I'll draw it at the last. Africa, if you put the climate charts, equatorial and all that, it won't fix. Africa, two maps you need, two charts. Here one chart, here one chart. Equatorial is still this much big, it will be there. Okay, you cannot go with one chart. So northern hemisphere you put one chart, southern hemisphere you put one chart. That is where you fix. South America, you'll need to put ulta. So South America, I'll do one for southern hemisphere, no problem. So we'll finish certain concepts and then we'll take it up. Okay. So we're stepping into geomorphology. So possibly rocks. I think rocks is possible. Interior of the earth, maybe to an extent, not all the concepts. Time, we don't know, like at least 7:15, 7:20. We hardly have 45 minutes. I'll try my level best. So let me start with the rock. So let me know the definition, then explain. A rock, not the rock, a rock is a portion of the Earth's crust. Which is composed of different minerals. Okay, is composed of different minerals. Full stop. A mineral has a definite physical structure and chemical composition. Definite physical structure and a chemical composition. Right. See, based on the definition, a rock is anything which you can pick up right where you stand. Meaning makes sense. So any portion, it can mean a portion of your road also. Like road is technically portion of the earth crust. You pick it up, you can call it as a rock. Meaning makes sense. So any solid part of the earth, which you can, break open from the crust, you technically call it as a rock. And this rock is composed of several minerals. So when we say several minerals, it can also include individual elements. For example, this rock which you pick up from the road might have gold. I am not joking. It might have gold. The only thing is, it will be in micrograms. Maybe it is of absolutely no use at all. Okay. The rock will have sodium chloride. It will have calcium sulfate. Like those are different minerals. Now, if you want to really define a mineral, it means it has a definite physical structure and a chemical composition. Now, what do you mean? See, when you write the chemical formula for sodium chloride, it goes something like this. Like you will write it like this, right? NaCl. Na represents sodium and Cl your chlorine. Correct? So when you write this, you'll never write the chemical formula as NaCl3. No. See, the thing is, if sodium chloride is to be formed, you will always have one part of sodium combining with one part of chlorine. That is what we mean by a definite chemical composition. It's always true. Based on the valency, two different elements are combining to form a mineral. Meaning makes sense. Fine, you take, it's not NaCl3, it's AlCl3. The valency of aluminum is 3 and the valency of chlorine is 1. So you need 3 parts of chlorine to combine with 1 part of aluminum. It is always true. It never changes. That is what you mean by having a definite chemical composition. What do you mean by this physical structure? See, even if you are from law background, medical background, you would definitely know that. I assume you know this. See, if you look at your crystal structure, every mineral will have its own crystal structure. It does not change as is. For example, you take sodium chloride. You might have drawn this diagram in school. I believe so. Law and medical students, I think so. Like FCC model, BCC model, where you can say that certain atoms or certain molecules will be present only in the corner of the crystal. Some will be present in the center of the crystal and all that. Some will be present exactly in. Okay, like that is how. So you take sodium chloride will always have the same physical structure. Aluminum chloride, always a definite physical structure. The crystalline structure will be the same irrespective of whatever conditions it is formed. Very rarely it will be different. For certain elements like carbon, carbon is different. Carbon is a very versatile element. You can have a very brittle structure like graphite. At the same time, you can have a very strong structure like diamond. Carbon is a different element altogether. But you take minerals, okay, whatever mineral you take, they always have a proper crystalline structure. That is what you mean by that. Okay. So now under this, we are going to learn types of rocks. Again, within types, only the broad classifications. That is enough for exam perspective. Ready? So 3 types are there. 3 types. Igneous, sedimentary, and metamorphic. Igneous, sedimentary, and metamorphic. Right? So we'll start from type 1. What do you mean by igneous rock? Right. So when molten magma reaches the Earth's crust, it cools and solidifies into rocks. I will explain. Just take down this line. I hope you get the idea. See, crust is only the top portion of your Earth's surface. Okay, think about crust as a biscuit. Okay, it's very, very thin. Okay, so beneath the crust, you clearly know there is some activity going on. Like the different types of activities we will explain during the course of the class. But you know that there is large amount of heat. There is absolutely no difference. Since there is heat only, you're getting volcanic eruptions. So picture this. So over your Earth crust, this is my crust portion, the topmost portion. Like this is where we are living. Okay, we are here. Okay. So to break open this crust, there are several volcanic eruptions. So visualize the volcanic eruptions it is trying to break through. One volcanic eruption is unable to reach the surface. Like there was good amount of heat energy, but possibly after traveling several kilometers, it kind of fizzled out. It is really not able to break the surface and explode. One more type of volcanic eruption is able to break open the surface. It's able to flow properly. See, both will form igneous rocks because once you start moving away from, there is a layer here which is having very, very high temperature. Once you have started to allow the magma to move out, naturally you moved away from a heat source. You move away from a heat source, your temperature will decline. Is it not? So decrease in temperature will slowly convert them into rocks. Is it clear? So your picture this volcanic eruption, your lava, just trying to explode, and the lava begins to flow out. During a period of time, it is going to cool down and form rocks. That is the process of solidification. But there is a difference. First and second will not form the same type of rock. You take the first one, for example, this one. The person actually did not reach the surface level, isn't it? He's kind of trapped still in, somewhere in the middle. This is an intrusive igneous rock. Intrusive, not a good color, isn't it? Even I feel bad. Intrusive, the first person, igneous rock. This is called extrusive, inner, outer, that's all. Number 2, who's able to flow outside, who's able to break open outside. Extrusive, igneous rock. Now, simple question for you. Between these two rocks, like both of them are going to cool eventually, but between these two individuals, who is going to cool faster? Who will cool faster? So who becomes Dhoni, 1 or 2? Yeah, very good, 2. Why? Because once you reach the Earth's surface, naturally there is more exposure to your atmosphere, exposure to hydrosphere. There will be more amount of water bodies here. So more chances you will get cooled faster. Listen. So extrusive igneous rock, which cools faster, will form basalt. Okay. This intrusive igneous rock, which cools slowly, will be granite. Okay. So your compositional difference, whether you form basalt or whether you form granite, is basically on where exactly the rock is formed. Okay. Whenever we mention granite, there is a Rajni film which usually comes to our mind. It's called Padayappa. Yeah. So there, Rajnikant becomes a big, what do you call? Wouldn't use the word, yeah, big industrialist because he actually finds that a mountain is mostly made of granites. And after that, he kind of becomes this, very big industrialist, fights villains and all that. But technically, according to the film, there is a big flaw. If you find an area which is mostly composed of granite, you should give it to government of India. You're not allowed to exploit the property. Biggest logical flaw in the film, but still the film became super hits. That's the power of Rajnikant, magic. Is it okay? Now, let's get the basic difference between these two. Between these two rocks, who's more denser? Always remember, we have this misconception that granite is more denser, but please understand, basalt is denser than granite. It's an important point. Now, since the granite is used for construction, there is a misconception that granite is more denser, but actually basalt is denser than granite. This will be an important point. That's why I'm writing in capital letters. We will use this under the principle of plate tectonics, where we understand mountain formation. But granite has more value, of course. Rajnikant has even more value. Fine. See, whatever the political turmoil and all that, on screen he's still the superstar. That no one can, argue. Is it clear? I'm more than happy that he's not entered politics, which means he's going to do more movies. More movies, more magic. Is it clear? Rajnikant, there is no logic. It's simply magic. That's all. You just watch the man. Now, moving further, type 2, sedimentary rock. Sedimentary rock. See, sedimentary rocks are kind of derived materials. You take igneous. Igneous actually means rocks born out of fire. Okay, igneous, it means fire. In Tamil, it is called anal parai. Is it fine? You take sedimentary rocks. Sedimentary rocks are derived. Derived meaning you take a mountain. Okay, let me run through the process before writing how they are formed. This mountain range will be experiencing several processes which will slowly denude it. There will be rainfall, rivers. Okay, there is constant alternate heating by the sun, at the same time cooling during night time. So several processes over hundreds and thousands of years will slowly break down the mountain. So let's say it breaks down over a very long period of time. As these sediments get disintegrated, this river is transporting all those sediments, and these sediments, after traveling for 50 kilometers, 60 kilometers, deposits in one area. Okay, let's say the deposition goes on for 500 years. 500 large-scale deposits. Okay. Now, after 500 years, let's say there is a sudden change in rainfall pattern. Maybe rainfall increases. Possible. 500 years, a slight change in climate, very much possible. Increase in rainfall. You increase in rainfall, then the number of sediments which are deposited and transported will increase, because rivers' erosive potential will definitely get exponentially higher. So more deposition. So let's say there is more deposition. And this goes on for possibly 1,500 years. Then again, there is one more new mountain which is nearby. From this new mountain, more deposits are coming in. So over a span of 1,500, 5,000, 10,000 years, large number of deposits get accumulated over a period of time. Now it's like this. Okay, try to picture a sandwich, okay, where you add layers and layers of sand and sand and sand. And over a period of time, this will keep on adding more weight. More and more and more weight. Slowly, over thousands of years, this becomes sedimented, this becomes compacted. Is it clear? Now, once it gets compacted, okay, slowly the process is called lithification. You will convert these fine sediments over thousands and thousands of years into rock itself. It's called lithification. stratification, where the sediments, okay, over a period of time get converted to rocks. So that is why it is called as sedimentary rock. You form the rock technically because of sediments derived from mountains. It's not just mountains, it can be anything. You can talk about a plateau region, okay, even from plain region, and slightly elevated plain, a depressed plain. From elevated plain to depressed plain, you can transport your sediments. So that is how sedimentary rocks are formed. So technically, sedimentary rocks are derived. They are not originally born. Original is igneous, born out of fire, not these. So igneous rock can write a poem on their own. I am born out of fire. Okay, the lyrics will properly match. Moving further, so let me put this in a proper way. Okay, like we never really wrote a sentence. Fine. So sediments which were eroded, which were weathered, eroded, and transported over several thousand years, gets compacted and lithified into rock structures, into rocks, lithified into rocks, called sedimentary. Full stop. Now we need to look at examples. You can understand different examples. I'll show you pictures also. Like with pictures, it's much easier to visualize. Yeah, I will explain that. Okay, like the NCERT grain structure. We'll see. See, before I go to examples, we'll look at one prominent feature of sedimentary rocks. Unlike igneous rocks, sedimentary rocks happen over several years of deposition, isn't it? So in sedimentary rocks, if you just want to look at a rock and identify whether it's sedimentary or not, sedimentary rocks will always have layers, always. Because the deposition has been going on for several years, so one layer over another. So it will always have layers. You visualize a rock, you see layers, it means it is going to be sedimentary. We will see pictures also, okay, with three prominent examples. So sedimentary rock has several layers, and we will see one by one. So three examples we will take. First is going to be sandstone. Okay, sandstone is a proper example of an inorganic sedimentary rock. We'll take that first. Sandstone. Okay, so this is brilliant, you know. Maybe it looks more like Photoshop. So this looks more real. Okay, so sandstone layers, you can clearly see those. See, thing is, things are never perfect in nature. And this is an example. You can see that the plane is not straight. It is convoluted. It looks more broken in several places, no? You see that? Several areas are, they are not straight at all. They're more inclined. That is how your layeral deposition will be formed. Perfect straight lines only we can draw, but not found in reality. You can clearly see it's convoluted. Sandstone. Number two, limestone. Limestone is a chemical sedimentary rock. Yes, of course, it can form due to biological action also, but limestone is more related to your chemical structures. Okay, when calcium carbonate precipitates over a long period of time, you get limestone. And you can clearly see, like, this is your road, and this limestone layeral deposition, you get right on the road, and you can see plants growing on top, right there. Yeah. So it's a clear deposition, entire layer of sedimentary rock. See, this entire layer would have taken thousands of years to build, thousands of years. But we can destroy it in a matter of few days if we want to mine certain area. That's the power of human beings. Okay, we can change landscape. So sandstone, limestone, and last one, this is an unlikely contestant. Usually people don't classify it as a rock, but it's actually is a rock. Coal. Coal is an organic sedimentary rock. Coal. Yeah, I can clearly see those dark layers, isn't it? Like, this is coal. This is sedimentary rock again, this one. This entire layer, this thick black color. Is it okay? So three types, three examples: sandstone, limestone, and then coal. Moving to the third type, metamorphic rock. metamorphic rock. Okay, so let me write this. Igneous and sedimentary rocks. Sedimentary rocks when subjected to high temperature and pressure, conditions, they are modified to a completely different rock. The process is metamorphosis. And rock is metamorphic. Full stop. You would have drawn this diagram in 7th standard or 8th standard zoology. Okay, this is the life cycle of silk moth or life cycle of butterfly. I think in some textbooks they would have given life cycle of tadpole becoming a frog. Okay, you would have learned it as metamorphosis. Meta means change and morphosis means change in physical structure. Morphology, study of physical structure. That is the way the rock is defined as metamorphic rock. Meta means change, morphology means physical structure. See, it can happen again. This is a derived rock. It is a derived rock and it can be derived from both igneous and sedimentary. Both igneous and sedimentary rocks, if you're going to apply them, if you're going to subject them to very severe conditions, you can ask me like, what do you mean by severe conditions here? See, maybe an already existing rock can come very close to a volcanic eruption. Maybe over that again lava flows. Maybe one more rock structure is actually crushed in an area where mountains are getting formed. Crushing or compression creates enormous amount of pressure. Like under plate tectonics, we will see how compression is technically caused. So once you apply compressional forces over rock or tensional forces, or let's say lava flows over the area, so that is what we mean by extreme conditions of high temperature and pressure. Because over the earth, there are several phenomena which try to modify the earth's crust. So when you apply these conditions, your rock structure completely changes. I'll take one example, you should get the idea. Limestone is a sedimentary rock. It can be derived from chemical properties or from biological meanings. Now, this sedimentary rock becomes marble. Marble is a metamorphic rock. You need immense amount of pressure conditions if you want to create marble, high amount of pressure. And you clearly know which is more beneficial. Marble is more beneficial for construction. The rock structure becomes harder. You place both limestone and marble together. No one would believe that marble was born out of limestone because limestone is very brittle, right? So you add enough amount of pressure, thousands and thousands of years, you'll be in a position to convert to marble. Okay, like Rajasthan is one area where marble is extensively mined in India. Makrana marbles, there is a geographical indication tag also. So those are called as metamorphic rocks. So technically you have a rock cycle meaning you will have lava. Okay, so this molten lava becoming igneous rock, right? So from igneous rock, you can form a sedimentary rock. Okay, both igneous and sedimentary rocks can be converted to metamorphic rocks. Metamorphic rock can be broken. Again, you can have sediments forming sedimentary rocks. Is it clear? Now, all these rock structures can again become molten lava. Okay, they can become lava again. Okay, like once they enter asthenosphere, we will see the process. This is your rock cycle. One is interrelated with the other. So let me retell the story again. Eruption of lava creates igneous, rocks born out of fire. Igneous breaks down, or a metamorphic rock breaks down, you will create sediments. You get sedimentary rock. Both igneous and sedimentary rock once you're subject to high temperature and pressure conditions, you will form metamorphic. And all the rock structures can again enter the asthenosphere and become lava molten materials again. So that is how the materials on the earth is getting recycled. It's a very normal process. Now, see, the thing is, if I start with interior of the earth, okay, will sedimentary rocks be formed from extrusive igneous rocks also? Yes, it can be formed from metamorphic also. See, the thing is, even if a metamorphic rock is hard, yes, of course, marble is hard, but that does not mean that marble is unbreakable. Like any rock, given time, it can be broken by nature. Anything can be broken. The thing is, I can start with interior of the earth, but it will be very premature, because if I start with the topic, it is better I complete it. So I'd rather take doubts. I know that I'm finishing early. It's close to 30 minutes, but it's completely okay, because if I start the topic, I don't want to, kind of finish it in the middle. So there were 2 questions. I'll take those 2 questions, and after that, still any questions are there, I will possibly take it over audio. So first 2 questions are on, I'll take it up. Others can leave. No problem. No one is holding you back. Is it clear? So let me finish those 2 questions and then take it up. Okay. So hold on, 2 questions were there. First is this, drawing for one more hemisphere, no? I'll take that. Slide 18. Okay, see, I think slides I will send it to you through Telegram. That'll be more comfortable. Anyway, I'll need to save the slides and send it to you. It's become more of a habit. Slides, don't worry, I'll send it to you. No issues at all. So before hand raise, okay, fine. First, I'll deal with hand raise, okay? I think that's much more easier. If hand raise is there, you have any doubts, please raise your hand. I think we'll deal with that. It's much better through audio.
Hello, sir. Am I audible?
Yeah, you're audible. Go ahead.
Sir, as we are seeing the climate chart, we have seen that Chinese climate as well as the Laurentian climate getting influenced by the Siberian coniferous, as well as Laurentian influencing the China and the other tropical marine also influencing the China. But we have not seen such a condition for Britain or the other savanna steppe. Why are they not including the others region? Why are they not also including that?
First one, you take savanna steppe. These 2 are grasslands. Right? So grasslands area, you will not find domination of trees. So the division of climate or the division of a forest area is quite, you cannot say that the transition happens over a period of time. Usually, if you take these 2 regions, for example, let's take North America. North America, there is no savanna grassland at all. Okay. South America, if you go, yes, it'll be like this. South America, you'll find savanna grasslands in a place in Brazilian highlands, Campas Cerradas Caatingas. And in Argentina, you will find steppe grassland. It's called Pampas. In between them, there will be a transitional grassland. It's very rare. It's called Gran Chaco. Like later, you can verify in South America map, Gran Chaco. So Gran Chaco is a transitional region where you find savanna moving towards steppe. You go to South Africa. South Africa's surface area is small. Surface area is small in southern hemisphere. You can't find the transition. So you take the grassland, that is the problem. In the continents, you do not find a proper transitional zone. Is it clear why grasslands is not possible?
Yes, sir.
Yeah. So you take a Mediterranean climate and British climate, you'll find the same problem. You take British. Okay, you take British region. I'm talking about Europe. Between your British climate and your Mediterranean climate, mountains will play an important role. Let me just try to refresh your memory. It's directly from map reading. You take Italy. Italy is in your Mediterranean climate. You go to British climate. It's there technically in France. So Italy from France or Italy to Switzerland. Between Italy and then Switzerland and France, you'll find Alps mountains. Alps mountains completely modify the landscape. Okay. Second thing, the surface area of Mediterranean climate itself is only 2 to 3% of the entire world. I think we have spoken about this. One place where you can see some consistency is only in your North America, where you move from California to British Columbia, because there is more conservation. And apart from more conservation, it's shielded by the Rocky Mountains, by outside influence. So apart from that, transition is difficult in different parts of the world. Is it clear?
Okay.
Yeah, so yes, Mediterranean is a small area. It's only 2%, 3% of the entire world. Good question.
Thank you, sir.
So I'll draw South America, no? So that's one question, one request. Hand raise irka? No. Okay, fine. I'll draw for South America. Then if hand raise is there, I'll take it up. See, please listen. When you draw any continent for the southern hemisphere, you put it ulta. Okay, you cannot have, like, you draw the continent. First, let me draw the boundary. Right. So if you take your climatic regions, this is my equatorial region, okay? One. Next is, hold on a second. Yeah. Right. Next is my desert. And number 2, number 3, that ends here. 4, number 5, okay, number 6. I'll use a dash line. I will tell you why the dash line. Number 6, number 7, okay, 6, 7, and yeah. I put the box right here. Now it looks okay. Right. Fine. See, the problem with South America is 2 climatic regions are not there. See, you might find it's, it doesn't make convey meaning. There are so many convoluted boxes. I will draw the original box, then I will convey. Okay, hold on. Same diagram, see? Reverse chart, equatorial is here. Okay, polar is here. Chart is this: desert, British, Mediterranean, savanna, steppe, Siberian, tropical marine, Laurentian, Chinese, and then Laurentian. We'll start one by one as usual. Okay, so first is my equatorial climate. Is equatorial climate present? Exactly. That's a larger portion of, so that's my equatorial Amazon forest. Right, Amazon is here. And Amazon extends over a pretty large area, this entire section. Is it clear? Number 2, equator is done. Second one is my desert climate, and you clearly know offshore trade winds. So let me draw the diagram of trade winds right here. Trade winds. As trade winds are offshore only, you get your Atacama Desert here. So this is Atacama Desert. Atacama, ATA. I'll just write ATA. You should be in a position to link. So this is my Peru Chile region. Got the idea? You move south even further, this region, this way you get your westerlies. Let me hold on. Westerlies. So southern section Chile. This you experience British climate. Now let's move up. Britain. BRI, I'll just write it. Between them, you get your Mediterranean climate because you have the domination of both trade winds, offshore, and your westerlies, onshore. Now, Chile got divided into several divisions as desert, then your Mediterranean, then your British. So 1 is there, 2 is there, 3 is there, 4 is there, no problem. Western side, there is absolutely no issue. You'll get Atacama, then you'll get your British climate, southern Chile, then middle is your Mediterranean Chile. Listen carefully. 2 climates won't be there because space is not there. After British climate, look at the one what is there? Siberia. Siberian climate won't be there. Now you might automatically ask me a question, sir, but if you take this section, it seems to be Siberian climate. It's not there. Why? Because Andes Mountains is present. Because of presence of Andes Mountains, if you remember, you will create a cold desert here called as Patagonia Desert. Patagonia Desert is present on the leeward side of Andes Mountains. Is it clear? So here, you will get wind systems descending down the Andes, and this is my Patagonia. Patagonia, this region. So that's why there is no Siberian climate. You take Laurentian climate, clearly land is not there. No chance. So two climates are completely absent. Polar climate, no chance. Polar climate is totally off. Even these two climates are not there. No chance you will get polar. Now let me try to fill the previous box. See what happens. This one is savanna. This is why soya plantations are more. Since soya plantations are more only, soya plantations are trying to invade into your Amazon forest. You get the idea? South of your soya plantations only, pampas, your steppe climate, pampas grassland. Got the idea? So this is my savanna, present, steppe present. Now on the eastern side, you will have tropical marine, the trade winds. Trade winds are present like this. So trade winds bring in large amount of rainfall. So this region, you have tropical marine climate. The eastern side of Brazil is tropical marine. Rainfall throughout the year. Just look at it. Offshore trade winds. So sea, wind is moving from offshore, land to sea. No rainfall. This is sea to land. So this is tropical marine. Tropical marine in this region. And finally, a very, very narrow portion, Argentina, Uruguay section. This is my China climate, natal type. China. CHN, this one, my natal type. Is it clear? So no chance of, so the problem with South America diagram is the continent is narrow, so it's quite difficult to fix it. But this is how you fix when you want to. So three climates are not there. Okay, there you had two climates out. We did not have savanna, we did not have equatorial. In South America, you do not have polar, you do not have Siberian, you do not have Laurentian. Now you should be more comfortable. Prakash, yes, you will have India map reading, but thing is, I won't be doing like India map reading. Indian geography, you have one more faculty. Mr. Karthikeyan will be handling. But yes, you will have India map reading. Don't worry. See, I think physical geography, I need 5 more sessions, I guess. Possibly 5 or 4. I don't know. It depends on time. Once it's taught, then Indian geography will start. Okay. Fine. I think other continent, at least you try, people. I've already drawn 2 for you. Okay, I will save it and then send it to you through Telegram. Is it clear? Why dashed lines? Dashed lines because climate is not there. Laurentian is not there. Siberian is not there. So that is why I drew dashed lines here. Others are contiguous. So if any further doubts are there, you can raise your hand. Else I will close the session. Is it clear? Any further doubts, do raise your hand. Else we'll close. Tomorrow we'll continue from interior of the earth. Because if I start now, it's a wrong start. I've already told you, isn't it? Yeah.
Good evening, sir.
Yes, ma'am.
Sir, regarding that grain structure in the igneous rocks.
Hold on. Ma'am, it's very simple. I'll just tell the basic idea. See, usually when a rock is formed, you know that it's clearly formed due to cooling process. If you give enough time for cooling, okay, you will provide proper time for alignment of grains. Proper alignment will take place. So you take granite will have proper grain structure. Okay, the sizes, if you look, the sizes will be very, very properly developed. And as an observer, as a geologist, if you look at the rock, you'll find proper grains. If your cooling is rapid, so this is slow cooling. Your cooling is rapid. You're not providing enough time. That is why at times basalt will not have any crystal structure at all. It will just look plastic. Okay, so this is alignment is very poor. So this is what you find in basalt. See, it's like this. I give you more time, you'll be in a position to arrange yourself properly. Less time is there, then this just the rock gets solidified. That's all. There is no crystal structure, crystalline structure, proper development. That's how it works. Is it okay now? Enough time? Good
Yes, sir.
Poor time? No crystals. Yeah, that's it.
Yes, sir. One more doubt, sir. For African climate, so first half we have to do the northern hemisphere chart, and for the second half we have to do the reverse.
Yeah, very good.
Southern hemisphere chart. Okay, sir. Thank you, sir.
Irukangala? Hello? Nilajyoti, I don't think it's audible actually. I can see that you're trying to speak, but you're not still audible. You try one more time. If it's not reachable, then you can send me as a message itself. It's still not audible. No, audible a little. It's still not audible. So maybe you can just send a message. It's fine. Certain times you might have this interruption. So you can send it as a message itself. I'll deal with it. It's fine. It's fine. Maybe some issue. It's totally fine. You send me as a hello. Yeah.
Hello, good evening, sir.
Go ahead.
Sir, actually, my question is regarding Laurentian climate in North America during winter, sir. So,
Yeah.
you to the eastern coast, sir. So while taking this moisture, there is a long land is there, long this portion of land is there. So doesn't it get dried or something like that, sir? Or does it reach fully to the eastern coast for rainfall, sir?
See, you need to look at it from how far away from water source. I'll give two different conditions. See, if my lakes are here, my land is here,
Yes, sir.
and this is my wind system, then the distance is quite high. Then there will definitely be dry land. This is the condition for Gobi deserts. Like this is my Mediterranean Sea and Caspian Sea. You move away from Mediterranean to Caspian to eastern part of Asia, you create Gobi deserts. But for North America, if you take, I think the map is there. Hold on. There. Hold on a second. You take North America, lake will be very close to the Eastern American region. North America physical. Yeah, right. So you can see in the region, lake is very close to land. So this is my lake region, this blue color L, and this is my land. So if a wind is going to move, it can easily pick up things. I just take from here and then give rainfall. Very close. That's why.
Okay. Is there any mountain range that is causing rainfall, sir?
No, it's not technically mountain. The mountain range is to the southeastern side. Appalachians are here. So they do not form like the entire part of Laurentian climate. It is more close to China climate than Laurentian. Okay.
Okay, sir. Thank you, sir.
Waiting for one query alone. Okay, Happy New Year again. Fine, we'll see. Try பண்ணுங்க. Yeah, we are trying to unmute again. Hold on. Still not audible, right? Possibly there is some audio connection. You can send it to me as a message, man. We will see. You send it to me as a message. I will take it up. Maybe you sent it already. What is the first type name under China climate? Ma'am, first type name under China climate is China climate itself. China and China. Okay. So waiting for the message, you can send it. What does pseudo monsoon mean? Pseudo monsoon mean a climate which does not satisfy all the characteristics of monsoon. Since you're asking, let me tell you, like, what do you expect when you say it's a monsoon climate? India is a proper monsoon climate, meaning there are three conditions. First is reversal of winds. Reversal of winds governing your climatic region. Number two, the wind reversal should at least have a reversal angle of 120 degrees. I'll give you one example. You take India. India is a perfect monsoon. Southwest monsoon. Reverse monsoon will be northeastern monsoon. You look at the angular twist, complete 180 degrees. You will not find this perfect shift in many places in the world. In certain places, like this will be the incoming monsoon. Reverse monsoon will not go exactly in the opposite direction. Maybe they move in the opposite direction, something like this, or maybe something like this. The reason is other factors will begin to influence. That is not the case with reference to India. Number three, you should have a wind velocity of at least 3 meters per second. Like a velocity. Okay, so all these three conditions are satisfied, then you call it as a monsoon. If this, like let's say only one condition you're satisfying, pseudo monsoon. Maybe two you're satisfying, pseudo monsoon. That's all. There's more to do with the list of conditions. Is it necessary to read about types of intrusive and extrusive igneous rocks? No, Akhilesh, I'll tell you, like that detail is not required. Right now, we stick to igneous, sedimentary, and metamorphic. Phacolith, dike, batholith, laccolith, all that we'll see later. Those comes under volcanic rock types. So volcanic landforms type, we'll see it later. Right now, don't worry about it. So Nilarjyoti Paul, would it be okay if you can send me an email? Is it fine? Like you do know my email ID, right? So if you can send it to me, I think I can respond better. I think, both of us are waiting for that. So you send me an email, I'll definitely get back. So that's the last one. Shall I close the class now? Maybe we can meet tomorrow. We'll just continue from interior of the earth. You can save the PDF and then close it out. Climatic regions for continents will be asked in exams. Ashwin, you won't get a question, explain climatic regions. They'll be asking about, for example, they can ask about world agriculture. They ask about world agriculture, you will need to take agricultural pattern in each and every climate and then you write your answer. So you will only get derived questions. Direct questions will never come in UPSC. They'll never ask that. Okay, you're talking about diagrams. No one is going to ask you diagrams. Diagrams is only for your own understanding. See, it is for revision. You learned all 11 climatic regions. Before exam, it is not possible for you to go through like 100 pages of class. It's not possible. So you have one climate chart, it's easy for you to revise. That's the reason I ask you to draw. They won't ask you, draw the climate chart diagram. No. Only for your reference. Is it clear? So that's the last query. Prelims preparation. I think I'll possibly talk about it when I close out the session. Okay, like possibly tomorrow we will see. Maybe not today. Is it fine? Because some might be missing today. I will talk about it. Okay, no issues. Fine, so that's the last one. I'll close the session for now. Fine, see you tomorrow. Just save this out. Take care. See you tomorrow. Bye.